Guys, this is the second video on graphing lines, and this one is we're actually finding the equations of lines giving certain information. I want to remind you first of our four different equations of lines that we've been talking about. First, slope-intercept form, y equals mx plus b. Whatever form I ask you to put it in, sometimes you choose a different form to begin with, depending on what information you're given. If you're given the y-intercept and the slope, start with this form, and then you can move it to standard form if, for instance, you're asked for standard form. Standard form, we rarely start with standard form, but know that a, b, and c cannot be fractions. They have to be integers to be truly in standard form, and a cannot be negative. So if you look through your worksheet and you have standard form where there's a negative out in front of this, that will not be correct. You need to multiply through by a -1. Point slope form is the best form to use when you have a point and a slope and you want to move it into an equation. So we will be using that a lot here. You rarely leave it this way. You usually want to move it into slope-intercept form or into standard form. And don't forget your bucks and Hoy. If you want to find a vertical line, it's going to be x equals some number, x equals 2, x equals 1,000. If you have a horizontal line, y equals a number. So save yourself time. If you see a vertical line, just write x equals and find the x coordinate that it passes through. So our first problem here is find the equation of a line with a slope m of 5 and a y-intercept of 2. Now this problem might have said at the top, put everything in standard form, but we don't have to start with standard form. I have a slope, I have a y-intercept, so I want to use y equals mx plus b. Y equals m is 5, b is 2. That's our equation. Now if I ask you to put it in standard form, we can subtract 5x from both sides, of course, and we get -5x plus y equals 2. Almost standard form, but we cannot have a negative up front here, so we need to multiply everything by -1. Okay, if we multiply by -1, we get 5x minus y minus 2. I wrote that wrong originally. So 5x minus y equals -2, and always check your answer. It only takes a second. Is our slope really 5? Yes. In standard form, we should have negative or opposite a over b, which is 5, so the slope is 5. Is the y-intercept indeed 2? Yes. Remember, y-intercept is where x is 0, so if we plug in 0 for x, the y-intercept would definitely be positive 2. So we know it only takes 2 seconds to check it, so make sure you do that. Now I want to point out, sometimes you'll have the same problem, but I'll give you a graph first. So in this graph, look, you have a y-intercept of 2 and a slope 1, 2, 3, 4, 5 over 1. So if you see a line and you see the y-intercept, again, you want to write out, okay, my y-intercept is 2, my slope, count, is up 5 over 1, and then put it in y equals mx plus b. And then again, if I ask you to move it into standard form, you would end up with this answer. So same idea if you have a graph where you are given the y-intercept. Next problem. Now here, you're given a slope and a point. And like I said, if you have a slope and a point, use point-slope form. So we're doing y minus y1 equals slope times x minus x1. So our slope goes in here is -2/3. I can put the negative with the 2 or the negative with the 3, doesn't matter. X remains x, that's our variable. The point is 5, so that's going to be our x1. We're going to plug that in for x1. Our y is 1, so we're going to plug that in for y1. Y minus 1 equals -2/3 times x minus 5. Now I told you a shortcut when you're simplifying in this situation Remember, if you had multiplied the whole equation by 3, on this side the 3 would just cancel, and only the negative 2 would be distributed. But you'd multiply this side all by 3. So if we go ahead and do that, we can think of it as multiplying the denominator to the left and the numerator all to the right. We would use this whenever we have point-slope form and a fraction is the slope. Remember to keep that negative with the 2. So I'm going to distribute that 3 to the left, 3y minus 3. Distribute the negative 2 to the right, negative 2x plus 10. Okay, so now I need standard form, so I'm going to add 2x to both sides, and I get 2x plus 3y minus 3 equals 10. And I need to get my 3 over here with the 10, so I'm going to add the 3 to both sides. And I'm going to get 2x plus 3y. If I add that 3 over, equals 13. That is standard form. Everything is an integer, a, b, and c, and there's no negative in front of a. Check it. It takes 2 seconds. Take the point, 5 and 1, and plug it in for x and y, and you'll have 10 plus 3 is 13. Yay! Give yourself a pat on the back. You got it right. Moving on. Now if you're given 2 points and you have to find the equation, again it's going to be easy to use point-slope for this because you already have a point, and you can just use the slope formula to find slope. So slope is y minus y, so I'm going to do 5 minus a negative 1, y1 minus y2. We started with this y, so we need to start with this x on the denominator. 2 minus 1. So we get 6 over 1, or 6 for the slope. So now, if I want to put it in this point-slope form, I can use either point I want to. So if I choose to use the point 2, 5, so I'm going to have 2 is x1, 5 is y1. Y minus y1 is 5 equals the slope I just got is 6 times x minus x1 is 2. That is the equation of a line. Now I just need to move it into the form that I'm asked for, which will be slope-intercept or standard form. If I distribute that 6, I get 6x minus 12. I need my x and y on the same side for standard form, so I'm going to subtract 6x. I need the 5 over here, so at the same time I'm going to add 5 to both sides. So I get negative 6x, y is still here, the 5 is gone, equals the 6x is gone on this side, negative 12 plus 5, which is negative 7. So is this standard form? Not quite. Make sure you multiply through by your negative to get rid of it, and you get 6x minus y equals positive 7. Takes 2 seconds to check. Let's plug in this point. If we plug in 1 for x and negative 1 for y, I'm going to have 6 minus a negative 1, which is plus 1, and 6 plus 1 is 7. So I can give it a check. Yay! I got it right. Now, know that if you have a graph that has 2 points on it, you can do this same method. So if you see a graph, and notice this is different from the graph on the previous page because we don't know the y-intercept. I might be able to guess what it is, but I can't tell for sure. Here I know this crosses through the point 1, negative 1 and through the point 2, 5. So I'm going to do the same thing. I'm going to use that point 2, 5 in standard form. I could have actually counted rise 6, run 1 to see that the slope is 6 and put that in for m in standard form. So same idea, if you're given a line with 2 points, find the slope, how much did you rise over run, and take one of the points and put it in for slope-intercept form. Point-slope form, excuse me. Moving on. Now, what about the situation, a lot of people ask me about this, where you're given an x-intercept and a y-intercept. Remember, these are 2 different points. Don't make this one point It's not the point 2, -3. And x-intercept is the point 2, 0, because it's where y equals 0. The y-intercept is 0, -3, because it's where x is 0. So again, we can find the slope by using y minus y, y2 minus y1 over x2 minus x1. So in this case, that would be -3 minus 0 over 0 minus 2, which is -3 over -2, which simplifies to 3/2. Okay, so now which equation should we start with? Point slope, slope-intercept form, or standard form? Like I said, it's not always easiest to start with standard form, but we do have the y-intercept and the slope. So why not use y equals mx plus b? The y-intercept is -3, so that's pretty easy. So we have it in y equals mx plus b form if you're asked to leave it that way. If you're asked to move it into standard form, you can multiply by 2 to get rid of the fraction and bring the x over so that you have it on the same side. Check it at the end. Make sure your slope is right. Plug in both points if you want to. That's another check. Okay, the next one, perpendicular to this line through this point. Now, as I told you on the previous video, if you're told that it's parallel or perpendicular to a certain line, don't bother graphing that line. Just steal the slope from it. What's the slope of that line? Opposite A over B. -6 over -4, which simplifies to 3 over 2. So there's my slope. There's my point, slope form. So y minus y1 is our y value, -5, equals m, 3/2, times x minus x1, which is 1. So like I said before, in point slope form, you can always multiply the top number to the right, bottom number to the left. This is the same thing as just multiplying everything by 2 to eliminate that denominator. So I end up on the left with 2y. This is plus 5 times 2, so that's plus 10, equals, distributing my 3, I get 3x. That's plus 1 times 3, which would be 3. So move it to standard form. I'm going to subtract 3x, -3x plus 2y. I'm going to subtract 10, equals -7. Change the signs so I don't have a negative. I'm actually multiplying by a -1 all the way through, and that equals 3x minus 2y equals 7. So how can we check? We can easily plug in this point, -1, -5, and make sure it is true. -3 plus 10 is 7. Yay! So I at least know it has the right point. Now you might want to double check the slope and make sure the slope's correct, but we're looking pretty good. Okay, last thing, I want to make sure that you look for your Vux and your Hoy. Look for vertical and horizontal lines. They're so easy to get the equation, but you've got to pay attention. If it says parallel to the x-axis, if a line is parallel to the x-axis, it's a horizontal line. It's a Hoy, horizontal line. 0 is the slope. Y equals a number is the equation. So y equals what? Well, if it passes through the point 1,5, y has to be 5. No slope. Remember, no slope does not mean 0. 0 is a number. No slope means undefined. Undefined is a vertical line. X equals number. What is x going to equal? Well, if it passes through 6, 5, x better equal 6. Through the points 2, 5 and 2, 6. If it passes through 2 on both of these points, this is going to have to be another vertical line where x equals 2. But suppose you don't notice that. You have 2 points and you start what we did earlier, where you try to find the slope. Okay, so you do y minus y, -6 minus 5, over x minus x, 2 minus 2, which is negative 11 over 0. Well, we know if 0 is in the denominator, that's no slope. That's an undefined line, an undefined slope. So as soon as you notice it's an undefined slope, don't try to put it in point slope form. Notice that's going to be x equals a number. X equals what? Well, the x values of 2. Okay, the last one, slope of 0. If you're told its slope is 0, you should immediately think horizontal line, that's ahoy. Y equals a number. What is y going to equal? Of course, the y-intercept, 5. You can also use these equations very easily if you are given a graph and it has a vertical or horizontal line that you're trying to find the equation of. If it's a horizontal line, you immediately know it's y equals a number. So if this is down at negative 2, y equals negative 2. Done. Great work. I'll be available tomorrow at Excel if you still need help.